Assalamualaikum and good day to you lovely people that are tuning into this video where I, Abdul Hafiz bin Abdul Ghaffar, a diploma in science student at UiTM Tapa, am going to present to you about the chemistry behind the rusting of metal. Let's get right to it, shall we? Before I start discussing about the chemistry behind the rusting of metals, I have to inform you about the definition of metal in chemistry terms. Metal is a substance with high electrical conductivity. Luster, which basically means how well the metal reflects light, and malleability, in which the metal readily loses electrons to form positive ions, or called cations. Otherwise, it's just defined according to their position on the periodic table. Metals can also be chemical elements like iron, alloys like stainless steels, and polymeric sulfur nitride. Moving on, what is rust? Rust is a hydrated form of a compound known as iron trioxide. It is a general term that defines a series of iron oxides. Its process is formed by the reaction of iron with oxygen in the presence of air, moisture, or water. Now, getting into the chemistry part, its chemical formula is Fe2O3, ferric oxide, combined with XH2O. What is the X in front of H2O? X varies for a different compound as it can have any number as it is a coordinate bonded water. Take X equals 10 for rust, which is Fe2O3 10H2O. This means that Fe2O3, ferric oxide, no matter how many water molecules condense, it is rust. The number of water molecules is variable. Now, in the topic of the rusting of iron rusting is an oxidation reaction. During rusting, iron combines with oxygen in the air in the presence of water to generate a hydrated iron trioxide. Iron is a reducing agent, but oxygen is an excellent oxidizing agent. When exposed to oxygen, the iron atom easily gives away electrons. The chemical reaction is described like this. Fe to Fe2, 2 plus charge, plus 2E minus charge. When water is present, the oxygen atom increases the oxidation state of iron and it becomes like this. For Fe2 plus charge plus O2, for Fe3 plus charge plus 2O2 minus charge. The iron cations and water molecules now undergo the following acid-base reactions. Let me clear the screen. These are the acid-base reactions. 2 plus 2H2O FeOH plus 2H plus charge. The other acid-base reaction is Fe plus 3H2O, same thing, FeOH 3 plus 3H plus charge. The direct reaction between the iron cations and the hydroxide ions also produces iron hydroxides. These are the iron hydroxides. O2 plus H2O plus 4E minus charge, 4OH minus charge. The other one is Fe2 plus charge plus 20H minus charge. FeOH. The other iron hydroxide is Fe3 plus charge plus 3OH minus charge. It becomes FeOH3. The iron hydroxides that result are now dehydrated, yielding the iron oxides that make up rust. There are many chemical processes involved in this process, and they all have one thing in common. They all require the presence of water and oxygen. As a result, the amount of oxygen and water surrounding the metal can be limited to prevent rusting. Finally, how do we prevent rust? The loss of iron objects due to rusting has a huge economic impact on the country, and it must be avoided. To keep iron things from rusting, a variety of techniques are employed. To keep air and water out, the majority of the ways require covering the iron piece with something. The following are some of the most prevalent ways to keep iron from rusting. Firstly, the rusting of iron can be prevented by painting. Coating the surface of the iron with paint is the most popular way to keep it from rusting. When the paint is placed on the surface of an iron object, it prevents air and moisture from getting into touch with the object, preventing rusting. To prevent rusting, day-to-day iron objects are all painted on a regular basis. Secondly, the rusting of iron can be prevented by applying grease or oil. When grease or oil is placed on the surface of an iron object, air and moisture are kept from coming into touch with it, preventing corrosion. Iron and steel tools and machine parts, for example, are rubbed with grease or oil to prevent corrosion. Rusting of iron can also be prevented by tinning. Tin is non-toxic, and its reactivity is lower than that of iron. Food cans are tinned, which implies that they have a thin layer of tin on them. As a result, when an electroplated thin coating of tin metal is deposited on iron and steel items, the iron and steel objects are protected from rusting. Tin-plated boxes are utilized because they are non-toxic and do not contaminate the food within. Well, that's all from me. I hope everyone tuning in could take valuable educational information from the video. I wish you all well on your educational journey. Goodbye.